Morning guys, today we'll be starting with the next topic from AC. Actually it was not continuation from our live class because I was not sure whether I will be completing the set topic as in the live class in the half an hour duration which was provided to you or to us actually. So we'll start with the next topic, which is LC oscillations, right? Clear? Now what do you mean by oscillation? To and from motion, right, which we have dealt in our pendulum etc wave motion or oscillatory motion in the 11th class. So in the pendulum, what does happen if you are having a bob? So about the mean position, the bob moves to and from, right? So here also in LC oscillation, from the topic we are to show that there are two components in a circuit, which is a LC, that is inductor and capacitor. Hence NC circulation or oscillation is something which happens in an LC circuit. LC circuit consists of an inductor and a capacitor. Now what do you, if a layman asks you what is an LC circuit, then you can say LC circuit is a device or a circuit which produces waveforms, which is in the form of electromagnetic waves. Right, that is, there is a complete oscillation between two energies, that is electric field energy and magnetic field energy. Right, now how does that happen is something which we are going to learn in this topic today. Okay, so before we move on to complete LC oscillation, we'll start with the capacitor. Right, let's say this is a capacitor. I connected with it a supply. So if you give supply to this capacitor, obviously it will be charged with positive and negative like this. Let's say this capacitor has been charged +2 plus Q naught and minus Q naught when you connect it with the supply epsilon. Then we removed this capacitor. Right, now this capacitor is fully charged. Right, now what happens if this capacitor I directly connect it like this? That is, plus and negative terminals of the capacitor are connected like this. Then what happens? Obviously the plus charge starts to move from this terminal because this is of high potential and this is of low potential, right? So charges always have a tendency to move from higher potential to lower potential. So when plus Q charges, right, starts to flow, it starts to neutralize the negative charges here, so that the charge in the plus section as well as charge in the minus section goes on reduced. At some point this capacitor will have zero charges, right? That means I will say now this capacitor is fully discharged, right? This is what happens. So first you charge here, then when you connect it like this, the capacitor becomes discharged. So that means there is a heavy flow of current from positive terminal to the negative terminal. So when there is a charge flow, obviously there will be a current flow, right? So charge goes on reducing and try to become zero, whereas current increases and try to become maximum, right? Clear? Right, now this is the scenario, right? So charge tries to become, suddenly starts to flow from higher amount to lower amount, whereas the current has a tendency to suddenly increase from lower value to higher value. Now what happens if in this circuit of capacitor I connect a inductor? Right, now this initial condition, okay, this we have just connected like this, right? So the inductor, what is the property of inductor? It opposes any changes, right? So what is the sudden change here? Sudden change is charge is trying to tend to become zero value. A current is having a tendency to become maximum. So this sudden change is opposed by the inductor, right? This is the introduction part. I have not dealt the entire LC oscillation properly. Now we will start from here now. Now initial condition, let's say, okay, now the pen is not writing up. Let's say t is equal to 0, right? T is equal to 0 condition, that means you are having capacitor, it is fully charged to plus Q naught and minus Q naught. You had an inductor like this and the key is still open. That means now what does the capacitor discharge? No. So the current is also equal to 0 because the key is not closed, the circuit is not is completed. Clear? Now, after t is equal to 0, the time is increasing, so suddenly the switch is closed now. So now what does the circuit look like this, right? The key is closed. This is key. Right. Now, initially the charge was maximum plus Q naught and minus Q naught. Now what happens? The charge starts to reduce, right? Suppose the reduced charge is plus Q and minus Q here, sorry. Plus Q and minus Q. Right. So the current is flowing, right? That's why the charge has reduced, right? Charge has reduced, the current is flowing like this from like this, right? The current is flowing like this, right? Now, what happens? The charge is reducing and the current is increasing. But what does the inductor do? It acts as a cell, right? Like this. In such a way that this cell will produce, right? The inductor will have an induced current. Let's say that current is I dash. This I dash is flowing in the opposite direction of that of the current I, right? So that the net current itself, I am going to write it I itself, right? Let's say the net current due to the opposition is also I, right? Suddenly, initially, if the inductor was not there, the current would have jumped easily, right? The current would have increased in a sudden way. Now, what does this inductor do? Inductor produces a I dash current in opposite direction of the current, right? So that now the current increases, but in a slow speed, right? But in a no, not in the earlier speed, right? The current increases, but not in the speedier way. It gradually increases. Clear? I hope you understood this much. Right. Now, as the time goes on, right, charge in the capacitor is reduced, right? The current is being flowed, right? Obviously, the current increases, but not in that pace. And the charge flow was initially, if the inductor was not there, the charge would have completely flow easier, right? Now, the current flow is reduced, means the charge is also flowing in a lower speed, right? So, as the time goes on, the charge on the capacitor is reduced, so that now the capacitor looks like this. It is zero charge, right? Like this. And capacitor, so that the current, what would, if the charge is zero, obviously the current will also has induction to become zero. But see, the current was increasing in the earlier section. So I can say here at this point, charge has suddenly become zero and current now has reached its maximum value, let's say I naught. At this fraction of second, right, charge has suddenly reached, not suddenly, gradually reached zero because of the opposition of inductor. The charge has now reached zero and current has reached its maximum value. Clear? Right. So I can write here I naught, sorry. Let's say this is I naught, right? Now if the charge is zero, then the current, right, for the next section, then the current also has to be zero, right? So I max or I naught was the maximum current which was flowing, that has to suddenly turn into zero because now charge is not present. At this second, on this duration, so at this interval, the charge suddenly became zero. So just at that time we found the current is maximum, right? Current is maximum. The next, after this interval, let's say again we see that the charge is zero, then further there is no flow of current, right? Suddenly then the current feels that, oh, I have reached the maximum value, now I have to become zero because charge is zero, right? But this is a sudden change, right? The current has to reach from maximum and it suddenly has to fall to zero value. This sudden change will be opposed by the inductor, whereas the inductor will not allow the current to die suddenly from maximum value to zero value. Clear? So let's understand the scenario, how it is going to be done. Okay. So this is the fourth figure, right? So this is our capacitor and this is our inductor, right? Now say the current was maximum, right? It is getting reduced. Suddenly it has to be reduced to zero, but it is now reducing and it has reached a value I. Why? Because current suddenly cannot reach 0 because that is opposed by the inductor, right? So let's say current was reducing and it reaches a value I, right? Then the L acts as a cell, right? So suddenly see current was maximum, was trying to become 0, means in between, let's say it was suddenly trying to introduce to 0 and in between some time it reached a value I, right? And while it reduced its value to I, at that time the inductor sees that, oh, current is trying to reduce, I have to oppose it, so it will not allow the current to reduce in such a speed. So current was initially in this direction itself, right? So if inductor has to increase the flow of current, right? If it has to increase the flow of current, means I dash should be in this direction, so that the current was suddenly decreasing. It should not be allowed to decrease in such a way. It means the I current has to be increased by inductor. So I dash will be in this direction, so that the cell will look like this, right? Inductor acting as a cell will look like this, right? So this will be negative terminal, this will be positive terminal, right? Now this I dash adds to current, right? So suddenly you say initially I naught reduced to say 2 ampere, initially it was 5 ampere, right? This I value is 2 ampere, means let's say I dash is 0.5 ampere. So what was intention of the capacitor? It wanted to reduce the current suddenly from 5 ampere to 0 ampere. So while it was traveling from 5 ampere, it reached a point 2 ampere. So suddenly the inductor saw that the current is 2 ampere. No, I shouldn't allow it to fall in suddenly to 2 ampere. So he provided a 0.5 ampere such that now from a outer perspective, 5 ampere has not reduced to 2 ampere, but it has reduced to 2.5 ampere, right? So the current has reduced but not in that much value. Clear? I'm just telling an example, right? So let's root a rubber, let's rub it off. This is an example because I want to make you understand, right? So I hope we can understood this much point. So what was now happening? Now the current is reducing but not in that value, that is our current goes to 0 but in a slow manner. Why? Because inductor is opposing the death of current now, right? Now current is flowing in which direction? From this direction, right? From here to here, right? Now this figure itself I am going to talk about this one, right? So if the current is flowing in this direction, this current, if you see now at this interval, right, current, is it equal to 0? No, it is not equal to 0. It has reduced from maximum value I naught, but I was writing small letter, so let's say I'll write it again like this. Is current equal to 0? No, it is not equal to 0. It has reduced from maximum value to say current, which is less I. Let's say write that. So in this figure itself, let's understand. So the current is reduced but it is not equal to 0, means if the current is flowing, means now the charge is there in the capacitor, right? That is the charge, or we can say the positive charge is moving from this left plate and sticking to the right plate. So the positive charge are sticking here and negative charge are here. Because positive charge, when it is moving out from this plate, means more will be the initially it was neutral, right? There was no charge. So if the current is flowing like this, means positive charges had been moving from here and it started accumulating here. So when positive charge moved from the left plate, so now remaining here it is minus charge and now here it is positive charge. Clear? Right. Now let's move on. Now I'm going to draw the same, right? Let's say the charge was accumulating, right? And the charge now reached a maximum value. Here it was negative charge, here it is positive charge, right? And the current was flowing like this. Sorry, let's say this is our inductor, right? Current direction I have to tell you again. So this is our circuit, right? Now initially, so what was happening in the initial section? Now the charge distribution, I hope you understood. Initially this was positive and this was negative. Now the plate has reversed its charge, right? Right. So inductor is giving back the charges to the capacitor. That's what I can understand. Right. Charge is now increasing. Right. And the current is now decreasing. Initially itself, right. Current's tendency is now increase. We understand that the current tries to move from the maximum value to what? 0. So still that is happening. Right. So current is becoming 0 now. Right. Now the current has reached a value, let's say 0. And charge has now reached the maximum value Q naught. Right. Now the capacitor start what? Now this is the condition. There's no current and there is full charge now. Right. Now what does the capacitor do? The capacitor starts to discharge again. Right. Now the current starts to flow, but in opposite direction. Why? So I wrote my both minus, this is plus, right? So current again moves from plus direction. So this is the current direction now, right? So initially, right, current became 0 and the charge has maximum. Again the capacitor says that I am fully charged, I want to discharge again, right? So the current flows in the opposite direction like this, and this current is not allowed to become increased to maximum value because inductor opposes it. So inductor opposes means inductor has to produce a current in this opposite direction, right? So I will draw the next diagram like this, right? So this will be our inductor. Let's say this is our inductor. So it has to produce an I dash current like this, right? It has to oppose the current growth. So that means now it will be acting like this cell, right? So this is minus, this is plus, right? This is our current direction now, right? Now the charge has been reduced from the capacitor. Initially it was Q naught was the maximum value. Now the charge has reduced to minus Q plus Q, right? Clear? Similarly, now I will go for the next diagram. So charge has reduced and it reached one point that now the charge and the capacitor have reached 0 value, right? So again the current now has reached its maximum value, right? All the charges has flown means now the current has reached the maximum value, which is I naught, and the charge is 0, current is maximum. Now current maximum, again it sees there is no charge in the capacitor, so current has a tendency to move from maximum value to 0 value, which is again opposed by the inductor by acting as a cell. It allows the flow of current more means now the inductor will act like this, right? So that this will produce an I dash current here. So more current flows in this direction. So actually I can draw it in another diagram if you want. So this will be, right, this is our inductor. So again I dash flows means the current initially it was I naught, it wanted to move to 0, it was not allowed. I naught changed to an intermediate lesser value current, which is I, like this, right? Clear? And if the current is still flowing means there is charge in the capacitor. So this section, that is the right plate, is losing positive charge. So this becomes minus Q, this is plus Q, that is positive charge gets accumulated in this terminal, right? Clear? So this is positive and this is negative, right? This like this one, right? So I hope you understood, right? From right to the left plate, right, the positive charge gets accumulated in and the cycle goes on, right? See, this is what the cycle was repeating again and again, right, initially. So I can move on to the next section also. Now the current is now gradually now reached from 0, it has to reach how much? 0 value, right? So the current now reached 0, and whereas the charge would have become maximum. In which way? Like this. So this terminal will become plus Q naught, this becomes minus Q naught, right? So this is our inductor. This diagram I have seen, right, as my first diagram itself. This one, right? So this entire cycle has happened in such a way that you have reached the initial figure itself, right? The left plate is positively charged, right plate is negatively charged, and this goes on. Yeah, this is what is known as LC cycle. I can hope you understood cycle. Now we are going to deal with the energy, what is getting oscillated in this case. Right, so we see that energy is first stored in the capacitor, right? And what is the energy in the capacitor? It is half Q squared by C. Then the inductor is storing the charge. So that what would the energy equation in the inductor is half Li square. Right. I will tell you where and all where are energy maximum and what and all are the energy negative. Talk in detail about how the energy is in the form of electric as well as magnetic. You know that the electric capacitor stores the energy in the form of electric field energy, whereas in the case of inductor the energy is stored in the form of magnetic field, right? And I told you what is the expression, right? We have learned it also, right? So how that happens we are going to deal here. See, this is the first figure which we learned, that is when the capacitor is just not connected or the supply has or is not discharging, that the capacitor is not discharged. That means there is no current flowing now, so the entire charge is in the capacitor. So this energy stored is just E is equal to Q squared by 2C, as you can see, very easy, right? In the second section, we know once it starts to be connected to the inductor, the capacitor starts discharging in such a way that the charge starts to reduce and the current starts to increase. That means the energy still is there in the capacitor in the form of Q squared by 2C. Initially it was maximum energy. Now since the charge is reduced, the energy stored in the capacitor, which is in the form of electric field, gets reduced, whereas since the current is increasing, the charge or the energy which is stored in the inductor goes to increasing, as well as I can say the energy is shared between the capacitor and the inductor in this form equation. Clear? Easy? Right. Whereas in the third figure, you can understand from the figure, now the capacitor has been fully discharged, right? So that the capacitor now is zero charge. Now I can say that current has also reached its maximum value. So that since the charge is zero, so I can say now the capacitor has not stored any energy. So charge stored in the capacitor is zero, but since the current is maximum, energy now stored in the inductor is maximum, that is half Li squared. So then the first figure, the capacitor was having the full charge, so the charge was in the form of completely in the form of electric field energy, whereas now in the third figure I can say now the energy is in the form of what? In the form of magnetic field energy. Now in the fourth figure I can see that now the charge is going on increasing, right? Why? Now the opposition was done by the inductor, so the sudden flow of or fall of current from maximum to zero is not allowed, right? So zero is not allowed means the current has to be given an opposition, or the fall of current from maximum value to zero is opposed by the inductor, so there will be an induced current, right, in the same direction. So the current reducing is there, but not in that fast speed. So current is reducing, but the charge is increasing. Why? So that means still the current is not zero, right? So current is still not zero means there is a charge flow, so that now the charge is provided by the left, right, by the left pole, or I can say left sheet of the capacitor, so that the positive charge gets accumulated in the right sheet. So this becomes positive Q and this becomes negative Q. Now the charge is increasing and the current is reducing. So there is both electric field energy as well as magnetic field energy, which is shared by the capacitor and the inductor in this form of the equation. Clear? So we'll go on to the fifth figure. As the figure depicts, now the capacitor was getting charged, right? Now in the fifth figure, as per the fifth figure which we have drawn earlier itself, so the left plate gets negative molely charge and the right plate is positively charged fully, minus q naught and plus q naught. That means now the capacitor is fully charged, hence the energy is stored in the form of electric field. So one swing is over, so electric field energy to mechanical, then mechanical to electric field, right? So energy in the capacitor, I will write it as half q naught square 2c. Whereas in the sixth figure, I can see now the charge is getting reduced again because the charge is now flowing and the current is getting gradually increased from zero value, right? Because in the fifth section, in the fifth figure, you can understand the current has reduced to zero. Now in the sixth figure, I can say that the left terminal or the left plate of the capacitor is getting charged, negative charge is getting reduced because the positive charges are getting flowing, or I can say balanced, right? So negative charge has reduced from minus q naught to minus q, and the positive charge section has reduced from plus q naught to plus q. So that means now the current flow is increasing whereas the charge is getting reduced. That means energy is shared between the capacitor and inductor in the form of the equation which is written here. Now the seventh figure, this is now the figure I have explained in the previous section itself, guys. I have drawn the figure again so that you guys can understand how to write the energy equation. So let's move on to the seventh figure. So now the capacitor has discharged completely, so no charge, whereas the current is now at the maximum point, which is I naught. So the energy is now stored in only inductor, which is E is equal to half L I naught square. So now the second time our inductor has got charged or getting energized. So I can understand 2 times capacitor and 2 times inductor has been energized. Now in the eighth figure, again now the capacitor is getting charged, plus q and minus q. The current is flowing, but the current is reduced because initially it was maximum value. Now it is gradually reducing to reach zero value. Now the charge is increasing, plus q and minus q, hence the energy is both there in the capacitor and inductor, hence the equation. Whereas the ninth figure I can easily understand. Now it has actually, the ninth figure is a repetition of the first figure itself. The capacitor is fully charged, the current has now reached zero value, means now the inductor is storing no energy, whereas all the energy is stored by the capacitor, which is E is equal to half CV squared, or you can write it as half Q squared by 2C. It is actually half Q squared by 2C because we are giving importance to charge, right? So please write it as E is equal to half Q squared by 2C. So I hope this much is clear. That means the energy is swinging between the capacitor and the inductor. Or I can say the energy is in the form of both electric and magnetic waveforms. Hence the output of an LC circuit is in the form of what? LC oscillations is in the form of electromagnetic waves, both the combination of electric and magnetic field.